The next question we have to face is, how are we going to measure things, and what are we going to measure and put over this network? I want to remind you, because you've probably forgotten by now with all this excitement, that we have a model of a viable system and that it is recursive. This means that in a pretty short time we had made all those recursive models fitting into each other like Chinese boxes. And of course the advantage of this is the enormous reduction of variety. If you remember that phrase from my first talk, the reduction of variety that this involves. Because if you're using the same model for everything, regardless of the level of recursion, and can write just one clever computer program to handle data on a particular loop of the homeostat, then you can use it at every level of recursion. And that's just what we did. So that was the first cut in variety. The second cut was this. We wanted to measure all sorts of different things. Production flow, thousands of tons of steel, a few pounds of this, money flows in escudos, sometimes 100 escudos, sometimes 1 million, numbers of people, absenteeism, social factors. If you measure all those things in their normal units, then you have a variety overload, and you have enormous problems on the computer because you now have to write special programs to accommodate the huge variations that these figures produce. Now, let's take a look at this. Here we define a notion called capability. That notion is not the same thing as capacity, because capacity is something pretty unreal. Capacity is something you never achieve. Capability is what you can do on a good day with everything going for you. That gets defined in the model, and this is the start of the quantification. Now, if you can actually do it, you can bet your bottom dollar there's something better, something I call potentiality, which means what we could do if we could solve some problems. If we could find a better lubricant, we could actually run this machine twice as fast. The machine will run twice as fast. We can't do it because of this missing lubricant. So the difference between capability and potentiality is, in fact, latency. It is latent in that situation that we could improve it. That is an actual measure of it, measured as a ratio. That will indicate, of course, where to put research effort, for example. And just as it's obvious that there is something better than capability to which we may aspire, we can also bet our bottom dollar that there is something worse, and that's what actually happens, because most of the time we don't even achieve that of which we're capable. And that actual figure, the one we're going to measure daily, can be contrasted with capability, which doesn't change, or doesn't change often. You have to alter your plant or change your practice in a major way to change capability. And that ratio between actuality and capability is the classic measure of productivity. And if you multiply productivity and latency together, then you get an overall measure of performance. Well, now you can see what we've done. Variety reduction. We have reduced these masses of figures, varying at all sorts of ranges, all sorts of factors, to 3 measures, all of them, by definition, ranging from 0 to 1. So, as I said, if we have a clever computer program which can handle figures, if they're just between 0 and 1, then we can put anything we like into this system, in any kind of units you care to name, and handle it. So that's what we did. Now I want to show you something. And I'm showing this to you live on the blackboard because it's quite a complex argument, and I'd like you to follow my hand and see exactly what I mean. Let us suppose we've been measuring something for a few days, and it's varying like that. And now we've got a new figure. There it is. What would you say about that figure? What is it? Now, of course, it looks pretty extreme as I've drawn it, but if we go backwards a bit, we may find a shape like that. Now, what would you say? You would no longer say it was extreme. This is, let's say, now. So on the strength of that evidence, you might very well predict that this is going to do something like we saw here. And that means that this point has no statistical significance, that it is a chance variation. Now let's take a second case. Here is the same series, roughly, as I started with, and again, the same new point. And this time when we look backwards, what do we see? We see this going on, and suddenly we see a peak. Now, that peak in the analysis of information is known as a transient. It means that something has just happened there, and so maybe this is a transient, and maybe this will go on like that. That's the second possibility. The third possibility, starting with the same series, looking back, we see this. Now, here's our new point. Maybe this is going to go like this, and we have an overall slope, which would be a very different case from the no change, chance variation, transient, no change. Here is a trend. And the fourth case I want to discuss, same start, same point, now look back, and we see perhaps something like this. Now that's known as a step function. There's been a fairly violent shift, and maybe this is going to be another such step. So, no change, transient, slope, step. These are the four possibilities that I considered for all the data which I was bringing into the system. And the computer program, which I described as fairly clever, takes every new point and computes the probability that the new point is one of those four things. Now that's a difficult job. Very elaborate mathematics. It takes an awful lot of programming. It took us a very long time. We did it. For those of you who are interested in the technicalities, it uses Bayesian probability theory and produces an expectation in the future from those points, which is very, very sensitive indeed. It has this other cybernetic feature that if the program finds something fishy, something suspicious, some high probability of a change, a slope or a step function, it automatically homes in on the data and uses more of the past history and